Hello students, let us now continue with exercise 7.11. So let's start with question number 8. Question number 8 says that I is equal to integral from 0 to pi by 4 log of 1 plus tan x dx. So because of these limits as 0 to a kind of limits, let's apply property P4 and see what we get. So I becomes equal to 0 to pi by 4 log of, in place of x we'll write pi by 4 minus x. Now using the property of tan a minus b, expand this, we get this. Now tan pi by 4 is 1, and so this gets reduced to 0 to pi by 4 log of 1 plus 1 minus tan x over 1 plus tan x. Solving, we get gets reduced to I is equal to integral 0 to pi by 4 log of 2 upon 1 plus tan x. Let's call it equation number 2 and the given question as equation number 1. Adding 1 and 2, we get 2i is equal to log of 1 plus tan x plus log of 2 upon 1 plus tan x. Using properties of log, sum of two log functions get reduced to log of the product of the two inner functions. So we get this 1 plus tan x gets cancelled and we are left with log 2, which being a constant gives us log 2 into x, which on applying limits gets reduced to pi by 2 log 2, but it is the value of 2i. So I comes out to be pi by 4 log 2. Now let's discuss question number 10, which says 0 to pi by 2 log sin x minus log sin 2x. So first of all, using the properties of log, we simplify this and write it as this 2 goes over here. It becomes log sin squared x minus log of sin 2x, which on using the property of difference of two log functions, we get log of sin squared x upon sin 2x. Now again, since it is of the kind 0 to a, the limits are from 0 to a, using property P4, we get 0 to pi by 2 log of sine of pi by 2 minus x is cos x. So sine squared x becomes cos squared x. Sine of 2 times pi by 2 minus x becomes sine of pi minus 2x, which is sin 2x. So it remains as it is, and so after applying the property, we get 0 to pi by 2 log of cos squared x over sin 2x dx. Now again call it equation number 2 and the previous one as equation number 1. Adding 1 and 2, we get 2i comes out to be log of this plus log of this function. Again applying property of log, this becomes log of sin squared x cos squared x upon sin squared 2x. Sin 2x can be written as 2 sin x cos x, which on applying the square comes out to be 4 sin squared x cos squared x. These can get cancelled. We are left with log of 1 by 4, which being a constant gives us log of 1 by 4 times x. After applying the limits, we get pi by 2 log 1 by 4. This is the value of 2i. So I comes out to be pi by 4 log 1 by 4. Again using property of log, this is log 1 by 4 is minus log 4. Now again 4 can be written as 2 squared. So again using the property of log, this becomes 2 log 2. So we get I is equal to minus pi by 4 into 2 log 2, which gives us minus pi by 2 log 2, which is the answer. Now coming to the next question, that is question number 11. We see it is from minus pi by 2 to plus pi by 2 sine squared x dx. We know that sine x is an odd function of x, but sine squared x being a square term is an even function of x, and so using the property P7, we can write it as 2 times 0 to pi by 2 sine squared x using P7. Now at this stage since it is of the category 0 to a, we apply property P4. We get I is equal to 2 times 0 to pi by 2 sine squared pi by 2 minus x, which becomes cos squared x. Calling it equation number 2, adding 1 and 2, we get 2i is equal to 2 times integral of 0 to pi by 2 sine squared x plus cos squared x, which is 1, and which on integration gives us x, which on applying the limits gives us 2 times pi by 2, and so I comes out to be pi by 2, which is the answer. On the same lines, we have question number 13, which is from minus pi by 2 to plus pi by 2 sine raised by 7x dx. But here sin x is an odd function of x, and we are having an odd power of sin x, and so this also is an odd function of x. So directly we get the answer 0 using P7. Now question number 14. It is I is equal to 0 to 2 pi cos raised by 5x dx. It is of the category 0 to 2a, where a is pi. So we'll try to use property 5 and 6. Now, in property 6, we know we have to check the f of 2a minus x. So what do we get? Cos raised by 5, 2 pi minus x. We know cos of 2 pi minus x is cos x. So raised to the power 5 will also be cos raised to power 5x. Since f2a minus x is equal to f of x, so by property P6 we have this integral will be twice of, now the limits get reduced to 0 to a, which is 0 to pi cos 5x dx. Now again we check, it is of the category. Again apply the property P5, treating 2a as pi now, and we try it out. Cos of pi minus x is minus cos x, raised to the power 5 will be minus cos raised to power 5x. So again using P6, since f of 2a minus x is equal to minus fx, we get the result is 0 directly, and so this integral comes out to be 0. Now let's try out question number 12, which is slightly different from the 3 questions which we have done so far. Now I is equal to this. Again it's of the category 0 to a, where a is pi. So applying P4 we get this. See here why we need to do the property, because of the presence of x in the numerator. We want to remove this x from the numerator, and P4 helps us doing this, because when you apply P4, this x becomes pi minus x. Sign of pi minus x is the same, and so denominator remains the same. If you add the given question and this one, what we get is 2i is equal to x. This x and this x gets cancelled. You are left with pi upon 1 plus sin x. Now this x in the numerator has got replaced with pi, which is a constant which comes out. Now we know how to solve 1 upon 1 plus sin x in the regular manner by rationalizing. So what we do is we multiply, divide by 1 minus sin x. It comes out to be 1 minus sin x upon 1 minus sin squared x, which is cos squared x. Now split open the numerator, we get sec squared x minus sec x tan x. We know the integral of both. This is tan x, this is sec x. Now applying the limit, at pi tan is 0, at pi sec is minus 1. So you get 0 minus minus 1 minus, at 0 tan is 0, at 0 sec is minus 1. So minus of minus 1 is plus 1. So ultimately we get pi times 1 plus 1, which is 2 pi. This 2 and this 2 gets cancelled. We are left with I is equal to pi. On the same lines, we can try out question number 15, which is 0 to pi by 2 sin x minus cos x over 1 plus sin x cos x dx. Now again, because it is of the category 0 to a, we apply property P4, and so I comes out to be sin pi by 2 minus x is cos x, cos pi by 2 minus x is sin x. So we get cos x minus sin x upon 1 plus this becomes cos x, this becomes sin x. Adding 1 and 2, sin and minus sign gets cancelled, cos and minus cos gets cancelled because the denominators are same. Whether it is 1 plus sin x cos x or it is 1 plus cos x sin x, they are one and the same thing. And so we get, on adding, the integrand becomes 0, and so the answer is directly 0. Now we come to a very, very important question, question number 16. It is slightly lengthy but extremely important. It is similar to the solved example 36, which is on page 346 of the NCERT. Right, now let's start with this question. I is equal to 0 to pi log of 1 plus cos x dx. Again 0 to a form, so we apply P4. What do we get? 0 to pi log of, now we know that cos of pi minus x is minus cos x, so we get 0 to pi log of 1 minus cos x dx. Adding 1 and 2, we get 2y is equal to 0 to pi log of 1 plus cos x plus log of 1 minus cos x. Again applying properties of log, these two come, we get log of product of these two, that is 1 plus cos x into 1 minus cos x, which becomes 1 minus cos squared x, which is sin squared x. Again using property of log, it becomes 2 log sin x. So we get 2y is equal to 0 to pi 2 log sin x. This 2 and this 2 gets cancelled. We are left with I is equal to 0 to pi log sin x dx. Let's name it equation number 3. Now again, see, if you use the property P4, what we get is pi, sin of pi minus x is again sin x. It doesn't help us. We get back again the same function. So instead of that, what we do is we use P6, treating 2a as pi. Okay, so what do we get? So, and we notice that sin pi minus x is sin x, and so log sin pi minus x is log sin x, and therefore by using P6 we get this becomes twice of this angle, becomes this limit becomes half, so 0 to pi by 2 log of sin x dx. Now if you notice, this integral is what is considered in example 36. Of course, there is a presence of 2 also here, but otherwise this integral is the same as that of considered in example number 36. Now let's start proceeding like example 36. So 0 to pi by 2, we apply property P4. We get I is equal to 2 times 0 to pi by 2. Now sin x becomes cos x because sin of pi by 2 minus x is cos x. Let's call it equation number 5. Adding 4 and 5, we get twice of I is equal to 2 is common. The integral and the limits is common, 0 to pi by 2 log of sin x plus log of cos x. Again applying the properties of log, it becomes log sin x into cos x, which can be written as log sin 2x over 2. Again using properties of log, we get 0 to pi by 2 log sin 2x minus log 2. Now you can split it into two integrals like this. Log 2 is a constant, so it becomes log 2 into integral of 1, which is x, from 0 to pi by 2, and hence we get I is equal to 0 to pi by 2 log sin 2x dx minus this becomes pi by 2 log 2. So let's call this one as integral 1, that is I1, and this gets carried down as it is. Let's call it equation number 6. Now before doing anything, let's solve the integral I1. I1 is 0 to pi by 2 log sin 2x dx. It is somewhat similar to what we started with in example 36, but here there is a presence of 2x which we want to remove. So here we put 2x as t, changing the limits, we get I1 is equal to half of 0 to pi, because on changing the limits also change to 0 to pi log sine t dt. Now again using the property P6, since sine of pi minus t is sine t, we get log sine pi minus t is log sine t, and so this becomes half is as it is. This becomes twice of 0 to pi by 2, because the limits get instead of 2a we have a now, so pi by 2 log sine t dt. This 2 and this 2 gets cancelled, and we get 0 to pi by 2 log sine x dx. So if you see from the previous steps, from step 4 we have I is equal to 2 times 0 to pi by 2 log sine x. So integral 0 to pi by 2 log sine x dx becomes I by 2. So here we get this is I by 2 using equation number 4. And this we call equation number 7. Substituting 7 in 6, we get I is equal to, in place of I1 we will write I by 2, and minus pi by 2 log 2 gets carried down as it is, and solving we get this I by 2 goes here, becomes I by 2 is equal to minus pi by 2 log 2. So we get I is equal to these two get cancelled, and we are left with I is equal to minus pi log 2. And with this we have covered all questions of exercise 7.11. You can do similar questions which are based on the properties on the same lines as this. Thank you.